Hello and welcome students to Unapulsar video classes. So today I will discuss some important thing regarding carbonyl compounds. That means it includes aldehyde, ketones, acid derivatives, all this in brief, so that you can solve different types of problems of competitives. Okay. So carbonyl compounds means basically RCHO, RCOR, starting with aldehyde and ketone parts. Okay. So how can we get the aldehyde and ketones? If we oxidize some primary alcohol with some PCC, pyridinium chlorochromate, or here that is mild oxidizing agent like copper, then this portion will be oxidized to CHO part. Actually, you should remember the trick that CHOH portions will be oxidized to C11O part. So if the alcohol is primary, you will get aldehyde, and if the alcohol is secondary, you will get ketone, C11O part. Okay. Again, we can get it by Rosenman reduction, RCOOH. When SOCl2 is given, then it will form RCOCl, and this RCOCl by Rosenman reduction, because BaSO4, quinoline, xylene, they are used as a catalyst poison, because otherwise it will be it will form aldehyde. Then again, if we don't use this type of substances like catalyst poison, then again it will be converted to primary alcohol. So to prevent this step, we need to use here some catalyst poison. So aldehyde can also be prepared from this. By Stephen's method, any RCN cyanide group, if we give here SnCl to HCl and some heating is there, then RCHO will be formed. So these are high. Again, ATAD reaction. ATAD means here toluene. If we give here chromyl chloride H3O plus, then it will form CHO portions. Okay. So these are some basic methods in brief by where aldehyde and ketone can be obtained. Now the thing is that if the question comes like some aldehydes and ketones are there, and the question comes, in which of the following nucleophilic attack will take place? Formaldehyde, acetaldehyde, benzaldehyde. The question is, in which of the following or the order of reactivity where nucleophilic attack takes place? Okay. So between carbon and oxygen, which one is more electronegative? We know carbon. That is why a delta positive charge is there. Oxygen delta minus charge is there. In this case, delta plus, delta minus, delta plus, delta minus. But in acetaldehyde compound 2, this partial positive charge is quite neutralized by the plus I effect of the methyl group. So the availability of the plus charge becomes less, and in this case, not only plus I, here due to plusr effect of benzene ring, or we can say minusr effect of CHO group, this partial positive charge again somehow neutralized by this benzene ring. So any nucleophile obviously will attack to this carbon first, because due to less steric hindrance and more plus charge availability. So the nucleophilic attack order will be like this. This is very important concept. Aldehyde and in case of aldehyde and ketone, aldol reaction, Clemenza reaction, these are very important. Already I have discussed in my aldehyde videos, in the videos lecture on Clemenza also. Okay, so I don't discuss it here. I am not going to discuss it here. Now the main thing I would like to discuss, that is the reaction of RMGX, that is Grignard reagent, RMGX, with any aldehyde and ketones. RMGX is one of the compound where R group has minus charge, because magnesium has dipositive charge, so 1 minus is counterbalanced by X and another one is X is halogen here, and another minus therefore comes by R. So this minus will move to the plus part, this minus will move to the plus part, and the product we will get, that is this part, is not it? And then if dilute HCl is given, then this OMgX part will be converted to OH group. So from aldehyde, with the reaction with RMgX, we can get here 2-degree alcohols, secondary alcohols, because alpha carbon is attached with 2 R groups. So this is the step up reaction. When carbon numbers we need to increase from aldehyde to alcohol, we can use it, this RMgX. And if RMgX is used in the ketone part, what will happen? Then obviously tertiary alcohol will be obtained, RCR, OMgX, and this OMgX again by the reaction with OH it can form OH, so you will get tertiary alcohol with the reaction with ketone and RMgX. Okay. So the next part is, how can we get benzaldehyde from benzene? By Gattermann and Gattermann-Koch method. Benzaldehyde to benzene to benzaldehyde. Very much important. If we understand the mechanism part, then no problem, we will have to remember, to memorize. Okay. If carbon monoxide HCl anhydrous AlCl3 is given to benzene, it will form benzaldehyde. How? That is CO. That means we have the structure like this, CO, carbon monoxide. Very reactive, because very unstable, as less electronegative will have negative charge and more electronegative will have a positive charge. Therefore, we know AlCl3, due to presence of vacant orbitals, it will form HCl plus Al minus Cl3. And therefore chlorine will attract this part, hydrogen will have positive charge, this minus will attack to this part, and the compound forming like this. Okay. So now this benzene ring is going to attack to this carbon due to this oxygen positive charge, so it will attract the electrons from this part. So it will form this, and this aromatization step occurs in the last part, AlCl3. So we will get the benzaldehyde. Okay. Just we need to see the mechanism to clear our conception that how benzene to benzaldehyde is being formed. Now this method is known as Gattermann reaction. Another method is known as Gattermann-Koch, where benzene to benzaldehyde again can be obtained, but the reagents are different. Reagents will be like this. In Gattermann-Koch reaction, reagents will be HCl, and H3O plus acid hydrolysis is there, then benzaldehyde will be formed. So before going to this, I need to teach you one trick, that is, if C triple bond N is there, then C triple bond N will be converted to C double OH part if acid hydrolysis is there. Hydrolysis is done in acidic medium. And if C double bond N is there, suppose NMgBr, or you can apply any group, then this C double bond N part will be converted to C double bond O part. Okay. So if it is H, then you will get aldehyde. If it is R, you will get what? Ketone. Okay. So now I am going to discuss this mechanism, how benzene to benzaldehyde is formed by this. That is, HCl means we have the structure like this, and we have H plus ions from HCl, as HCl is very strong acid. So this lone pair can be donated here, And we know between nitrogen and carbon which one is more electronegative, obviously nitrogen. So these bonded are more attracted towards nitrogen as it has a positive charge. So a partial positive charge is developed on the head of carbon. Now benzene ring is there, so the compound becomes like this. And if we hydrolyze this part, then just we have learned this C double bond ON group will be converted to C double bond O group. So by this method benzene can be converted to benzaldehyde. By HCN HCl, this is known as Gattermann-Koch method. Okay. Now the next part is that Clemenza reduction. We know Clemenza reduction, in which aldehyde on ketone or ketone part will be converted to simple alkane. Aldehyde and ketone part will be converted to simple alkane. C double bond O will be getting converted to CH2 group. By which reagent? That is zinc, amalgam and concentrated HCl. And if we put here any ketone part, then also if we use this reagent, then it will form C double bond O to CH2 part. This is known as Clemenza. But when the reagent is hydrazine, that means reagent is hydrazine, ethylene, glycol, C2H5O minus Na plus, this type of reagents are there, then what is happening? Then again this C double bond O group will be converted to CH2 group. Okay. But this reaction is known as Wolf-kishner reduction. Now the problem is that Clemenza can also form aldehyde or ketone to alkane, and Wolf-kishner is also formed aldehyde and ketone to alkane. Then when we should apply? Then we need to know the concept that if a problem is there like that, it has come in JEE Mains that ketone portion will be there, and we need to convert this from this C double bond O to CH2 part, C double bond O to this CH2 part. Then 4 options are there, that in 2 options, option A, Clemenza reagent is there, that is zinc amalgam concentrated HCl, and another option is Wolf-kishner reduction is there, that is hydrazine. So what we need to use here? We need to use here Wolf-kishner, because if we use here zinc amalgam and concentrated HCl, then what is happening? In the medium, H plus ions are there due to HCl. So this can be also protonated, and after protonated, it has obviously, it will remove H2O part, and therefore a carbocation is formed, and in this carbocation the Cl minus may attack. So if we use here Clemenza reduction, then this C double bond O may get converted to CH2 group, may get converted, but the OH group also will be converted to Cl, but that is not a desired product. That's why in this reaction, for this conversion, we need to use here Wolf-kishner, not the Clemenza part. Okay, this is very conceptual problem. And the next part is very important reaction, that is benzoin condensation. Benzoin condensation means what is happening here? In benzaldehyde, if we give alcoholic KCN, and heating sign is there, H3O plus is there, then it will form the product, that is benzoin. We can apply a trick, that is if it is oxidized, then one molecule is oxidized like this, and if it is reduced, then one molecule is reduced like this. then this HOH will be eliminated and forming this compound known as benzoin. Okay. So just we would like to see the mechanism, that is benzaldehyde is there and Cn minus is there. So nucleophilic attack takes place and here the molecule becomes like this. Then this O minus will take hydrogen from this part and it will form a nucleophile like this, OH, C minus and Cn, and this C minus now becomes a nucleophile. So it will attack the another part of benzaldehyde, because one means not only one molecule, many molecules are there. So now the structure becomes O minus H plus and this part. So this O minus now take the electrons from this and the structure it will form, that is O minus Cn OH H and benzaldehyde, and this minus will form a bond, Cn will be eliminated and you will get the product benzoin. So this is the mechanism of benzoin condensation. So if we see the mechanism of most of the name reactions, then it will not be a problem to remember the name reactions part. Okay. Next we have a very important portions, that is NH2Z type reaction and why the pH of NH2Z type is maintained, NH2Z type. Okay. So if any RCHO and any ketone is there, then it will form, we know DNP test, dinitrophenyl hydrazine, it will eliminate water and it will form RC double bond NZH, it will form RCR double bond NZ, okay, this type of compounds. But in this case, the medium should be acidic but not so acidic. That means the pH of the medium should be in moderate region, that is nearly 3.4 to 5. Moderate region we need to maintain the pH. So why the moderate pH is maintained? Because we need to see the mechanism part. This is the short trick, we need to see the mechanism part. So if in acidic medium the reaction takes place, then medium contains obviously some H plus, so a protonation part would be there, and between carbon and oxygen which one is more electronegative? Obviously oxygen, it will have a positive charge, so it can attract the electrons from this part, therefore a delta positive charge is there, and NH2 part is a good nucleophile, it attack to this part and you will have the structure that is OH H NHHZ, and as it has donated one electron, it will have a positive charge. So now the question is, protonation of this part can take place and the structure becomes like this, OH2 plus H NHZ. So now this electron donation will take place and OH2 will be eliminated and the product becomes NHZ, obviously a positive charge, and in the medium H2 ions are there, so it can form this. So for the occurring of this reaction, obviously medium should be acidic in nature. Then if the medium is more acidic, that means if pH is more lower, then what will be the problem? The problem may be that more H plus ions are there, then this type of protonation can also take place. Then it will form NH3 plus and Z. So now it becomes an electrophile, and therefore this attack cannot take place because it is acting as nucleophile. That is why the pH should not be basic and the pH should not be more acidic. So the pH range nearly moderate, that is 3.5 to 4.58, 4.5, like that. So in my next videos, obviously I will discuss more important questions on the conceptual problems of the organic chemistry. Okay, so to get this, just subscribe, and if you think that it is to be liked and shared, so like and share. Okay, thank you.